Okay, welcome everybody to another TIFR problem solving session. So today's question, it is especially designed as a question for Westeros approximation theorem. So what does Westeros approximation theorem tells us is that if you have a continuous function on a closed and bounded interval, that means on a compact uh, I mean, it's in a closed and bounded, that means a compact interval of R. Then if you have a continuous function, then you can actually approximate it by polynomials. That means there is a uniform convergence to that continuous function where the sequence consists of polynomials. Okay, so the Westeros approximation theorem tells us this. So Westeros approximation theorem. So in short, if I do not want to get into too much details, in short, what it tells us is that if you have a continuous function from AB to R, then there exists a sequence of polynomials that converges to F. And this convergence is also uniform. So this is one way, and this is one statement. Another equivalent statement is that there exists a polynomial Pn such that Pn minus F is less than epsilon. So whenever I say Pn minus F, I'm taking this for all x in, so this is for all x in a comma b. Okay, so this is the integral part of this question. Okay, because see, in this question what you need to figure out is that this limit, you need to figure out this limit, right? So what is our goal? So first, since f is given to be a continuous function on a compact set like this in a closed and bounded interval, so first we will compute this integral when f is a polynomial. And since I know that, let's just call that polynomial some p. So since I know that there exists a polynomial p such that mod of f minus that p will be always less than epsilon. So this integral can, I mean, after limit n tending to infinity, wherever it will converge, it is decided by where it is getting convergent when I take my fx to be a polynomial. So this is a trick that you can use everywhere whenever you see a continuous function defined on a closed interval and you have a limiting condition like this. So what is our steps in proving this? So the steps in proving this are this. So let's say the first step is, by using this, let's take some p of x such that mod of f of x minus p of x is less than epsilon. Okay, so what does that mean? That means in the interval a comma b, these two functions are almost equal. So then if I take my p of x to be of this form, let's say some a k x to the power k equals to 0 to n, and you just replace this in this integral, limit n tends to infinity 0 to 1. Okay, so just a second. So there is this n x to the power n is also there. So n x to the power n into summation over e k x to the power k with obvious notation, so 0 to n. So this limit is practically if you compute it, it will be ak, k equals to 0 to n. Okay, so how will this turn out to be summation over ak? So let me just give you an example. If you have a0 a1 and that is going to get true, so if you take this, so the function that we have something like this, n x to the power n, let's say a0 plus a1x plus a2x squared. So then this actually gets broken into pieces like this: a0 n x to the power n plus a1 0 to 1 n x to the power n plus 1 plus a2 0 to 1 n x to the power n plus 2, and all these are under the limit, like limit n tends to infinity. So now if you just compute it, so then you will see that this is nothing but limit n tends to infinity a0 into n by n plus 1 plus a1 into n by n plus 2 plus a2 into n by n plus 3. Okay, so if limit n tends to infinity, this is nothing but a0 plus a1 plus a2. All right, so this is precisely the same thing that will happen whenever I am just taking, instead of 2 I am just taking n, I mean standard polynomial, so it will just break. Okay, so the moment you do this, so what is this? This is nothing but your p of 1. Okay, because if you take p of 1, so p of 1 is nothing but summation over ak p 0. So now by the Westeros approximation theorem, what have we actually taken? We have taken p such a polynomial such that mod of f of x minus p of x is less than epsilon. So then what happens to these two integrals? Limit n tends to in, so let's just forget about yeah, so limit n tends to infinity n x to the power n f of x minus p of x. So then this is also less than epsilon. Okay, so that means what? That means if you take these two integrals, limit n tends to infinity 0 to 1 0 to 1 n x to the power n f of x, and limit n tends to infinity 0 to 1 n x to the power n p of x. So since this thing converges to p of 1, by the Westeros approximation theorem, this thing will converge to f of 1. Okay, because of the Westeros approximation theorem that we are actually using here. Okay, so the moment you use Westeros approximation theorem, so this will, so this is, so this implies this by the Westeros approximation theorem. All right. So hence the answer to this question will be f of. So what you should take it from here is this, that whenever, so what is the remark, the competitive exam remark that you should always have in the back of your mind when you are trying to solve these questions? So the remark is, whenever you have any continuous function from a closed interval a comma b to r, and there is this type of limit n tends to infinity, some I mean, let's say n square and stuff like these are here, and you have been given f of x, and you are asked to compute what the limit is. The Westeros approximation theorem tells you that precisely use f of x as a polynomial. If you can compute the integral over f of x as a polynomial, that is precisely where your main given integral will converge to. So this is the best usage of any this is the best usage of Westeros approximation theorem. So let me tell you again. So if you have a problem like this, so let's say n square, this gx is given. So this is something given. Okay. So given means it has an explicit form, and you have been asked to compute what is the limit of this, provided that f is given to you as a function from a comma b closed interval to r, which is also continuous. Okay. So then Westeros approximation theorem compels you to use f of x as a polynomial. So use f of x as a polynomial and see where the limit converges. That is precisely the point the entire limit will converge. This is the application of Westeros approximation theorem. Okay. So thank you for joining us today. This is one of those problems in TIFR which you can actually solve if you know certain theorems properly. So we will meet again next time with another problem from TIFR. Thank you for joining.